Hi. See the we will see the LLM code implementation. In last at the interface waveforms regarding the LLM interface. It is very simple. It is just like the memory read-write operations. So for the writing process or reading process, we are taking the memory as a slave IP. In that case, this offset becomes our address. W data will be writing address data, and the R data valid is coming out from the that memory. So we have to make some glue logic, and then we can interface the memory over there. So we are looking, either you have to refer to our earlier part 1 for the LLM interface. For the writing process, the process is very simple. We have to put the WR RD equals to 1. So in that case, we have to put logic 1 address, put a data, and make a request for the slave, so that it will write the corresponding data to corresponding address. So it is simple memory related interface. So we are not bother about any ready signals. We are assume that it is kept 1. So this is one case where we can try to write some memory location to that memory, and also for the wait state, but we can go for the consecutive writes. In that case, we have to keep the request high until we require the data transaction. So similarly, we can read the process. In that case, we have to just pull down the WR line to be 0. Okay, so we have to just make it sure that it is low. We have to provide the address and then request. After some time, the slave memory acknowledge with the data as well as the valid signal. So consecutive read also possible. We have to keep the request signal high and change the addresses. We can get the consecutive data from that memory. For example, we are trying to code for the LLM slave interface or IP. For that, we can refer this code. So we are providing the corresponding all the signals, LLM slave interface, clock reset, everything is there, okay, according to the diagram. And we just make sure that the address and the data width is a parameter oriented, so that later on you can resize that. So here we initialize the memory. So the simple task is there. If positive edge is there and reset is happen, it is synchronous reset. So we place the R data 0, then valid also 0, and then make ready equal to 1. In else condition, if it is not reset, but there will be the request coming, so we make the ready equal to 0. And if it is going for the writing process, so we have to put the W data to the memory, whatever the offset specified by the user or master. In else condition, we have to pull the data from the memory and give it to the R data. It is very simple one. So for the test bench, we are providing the task-based test bench. These are the parameters. These are the registers, wires for the input outputs, instantiation of the duck, and the clock generation, initial conditions, So there is a two tasks are there, one for the write process and the second for the read process. So writing was, we know that when there is a request equal to 1 and WR equals to 1, then it's going to be write. We have to just provide the address and data. These two things are as a input to this task. Okay, so we wait for the 1 clock cycle and then we release the reset. So it is for the single write, and the same thing is happen, only the RD equals to, sorry, R WR equals to 0 only. So in that case we have to wait one clock cycle, and whatever the data is present in our data, we have to make it as a data out. Again we have to release the request. So in the begin we have to wait for the reset happening there, then 1 clock wait, then we start the some message like we are starting the writing process. Write memory is the task, address, data. You have to again flash the what we are writing and what at what address. We are writing at location 10, 11, 12, and corresponding we are reading 10, 11 and 12. Sorry, 10, 11. Corresponding address is also written or read it by this initial block. So we try our best to get that thing done using the VCS. So we back to the VCS. So you can check not anything is changed in this file. Okay, only the whatever the list file I changed that only. Just make top is our test bench name. Okay, it will take time. Okay, control all, control 4, and then we just add one memory there. Okay, control 4. So in this we have the form window and the D window. Okay, just hit F for zoom fit. As you've seen there, the request goes 1, address is placed on offset, that is 10, the data is being placed on WD, and similarly we write that at location 10, 10, 11, 12. Okay, but with 1 clock and the wait of 1 clock as well, it is not consecutive, but we are writing one by one. So we are also getting the data at our data one by one. Okay, same data, you can have that. Okay, so also we have the messages here, all are passed. Okay, so in this way we can have the LLM interface code implementation and the cross check with these task files. So we can also go for the consecutive read or write process. If we make if we remove this one, so it will go for the consecutive read write. Okay, so we can check also. Go back to one more time. Control Alt, Control 4. Again we can add one memory there. Control 4. Go back to waveform window. We can have a F5 zoom bit. Now you see that on every clock it is writing. Okay, so it is a consecutive write. We are keeping the WR equals to 1 for the consecutive 3 cycles. So consecutive it is writing the 3 locations, you can see. So we are reading the consecutive locations as well. Okay, so it is verified that it is okay code, we can say, for the same. Thank you for all, and please support me, subscribe me, so that I can bring more good codes and designs to you. As in this kind of video YouTube channel, actually there are not much of the viewers are there, so whatever the viewers will seeing this, so please subscribe me, support me. Thank you.